Hello, everyone, and welcome to our webinar. My name is Johanna Manso, and I am the Logistics and Events Manager at the Internet System Consortium, and I will be your host for today. Our panelists today are Mr. Barry Green and Mr. Vernon Shriver, and the title of the presentation is Bind's New Security Feature, the DNS Firewall. A few quick points. All webinar participants are automatically muted upon entry. We will have several pauses during the presentation to answer questions from attendees. To submit a question, you have two options. Option one is to type it into the Q&A area at the bottom right-hand corner of your screen. Option two is to click on the Raise Hand button. When the time comes, I will unmute your microphone for you to ask your question. If you have any questions with regards to WebEx logistics, please forward them to me via the chat area. Now, without further delay, I give you Barry Green.
Okay, good. I'm unmuted. All right. Thank you, everybody, for coming and attending. This is a webinar session that we're now starting to do focused towards Asia Pacific. So today is Wednesday our time. It's Thursday morning over in Asia Pacific, over in Hong Kong, Singapore, Korea, China, Australia, New Zealand, all the places over there. So those of you who are from that region, spread the word. This is something that ISC is going to regularly be doing and reaching out to our constituents, where we're focusing to make sure we hit all the major time zones, so that way we can reach out to all our buying, DHCP, SIE, all the different people we work with. Myself, Barry Green, Vernon Shriver is also one of the key heavy lifter coders who did this DNS RPZ. You know, I thank him for being on this late. This is our third webinar for the day. And so what we're going to be doing, so some more on logistics. Later on, we're going to be posting this presentation onto our knowledge base. You can go kb@isc.org or deepthought.isc.org. And for those of you who are longtime buying users, this is like new for ISC, and we're going to be posting, this is going to be hopefully a year from now, as our engineers keep on posting more and more materials up there. This becomes one of your first places you look when you're scratching your head over a bind issue. Also follow us along with Facebook, Twitter, LinkedIn. We're connected to all the different social media types, and that helps, you know, stay tuned and what's happening and the developments over at ISC, because we're involved with so many things that keep the internet moving forward. So why are we here? If you've done any searching, or you kind of looked at the landing page and you clicked on some of the links, you'll see things about Paul Vixie talked about taking back the DNS. Fortunately, DNS has been vital to gluing the whole internet together and keeping the whole internet movement moving forward. Having an open source version has been an integral part of that, because it allows a little country like a service provider in Vanuatu to have the same quality of DNS infrastructure as AT&T. The infrastructure is resilient. It's really good for all the respectable internet citizens out there, but the structure allows bad guys to take advantage of it. And the bad guys are taking advantage of the DNS resiliency and distributed autonomy to do things where they're victimizing citizens all over the planet. And something's got to be done about it. So ISC, we're not a sort of organization that sits on our hands. We're known for actually doing things. And so we've been doing things within our capacity and capability and expertise, which is DNS is a strong part of it. So Act 1 was massive deployment of passive DNS. We're going to have more webinars on passive DNS and what we're doing with that. What that does is allows us to pull back the curtain on what the bad guys are doing. It's a technology that any of you who are running DNS resolvers would love to talk to you if you're interested in putting sensors in, and then in return you actually get access to the data sets, the compiled data sets, to allow us to see what the bad guys are doing. So this pulls back the covers on them. But then when you pull back the covers and you see, like, here's all the next 100 domains they're going to use for a spam run or a phishing attack, days before they do it, we have to do something about it, have to do it fast. And this is where we come up to Act 2 with the DNS RPZ. So our agenda here is we're going to go through 4 major areas. We're going to put Q&A between each one of them. As Johanna mentioned, you can type the Q&A down there. As you think of a question, type it in. We'll have plenty of time for Q&A on this. We're going to be, the first part is a quick talk, so you can kind of get an overview of it, get a good general principles and concepts. Then I'll go through a user scenario, which is kind of like my personal user scenario. I was one of the many different people in the security community who was talking to Paul Vixie and Vernon Shriver that, you know, this is a problem, we need some help here, and they came up with a solution. And then we get some more details on DNS RPZ, and then we'll talk about 3 of the providers that have launched their public trials, so you know you can get your blacklist from them. Big gratitude, number 1, to Paul Vixie and Vernon Shriver for actually doing the specification and doing all the code and scratching their heads, and they're still doing it. DNS RPZ is not finished. We'll probably evolve to, you know, a version 3 or 4, you know, where right now they're collecting lots of feedback for next versions of it. You'll hear more about that. And you know, so if it wasn't for their passion, we wouldn't have had the tool that we have right now. Then we had to get it into production bind. And that's thankful to ISC bind engineering team, because working to integrate it into the mainline feature set. So that's why we now have it in production bind 9.8 version, bind 9.8.1 right now. Eric Zykas, fantastic partner. A lot of these slides I'm presenting is like back and forth, him and I working together. We've presented them. We've been the 2 key presenters on the DNS RPZ technology in the industry at different conferences and stuff. And then also a big thanks to the DNS providers who have come forward, Spamhaus, Serval, and Internet Identity. Here, Simon, Arnie, and Rod have been fantastic. As a matter of fact, Rod actually did an article in Security Weekly, which I'll give a pointer to later, that you know, he's disappointed because the editors of the magazine cut out the DNS RPZ part. So we finally, Vernon and I were looking at this and said, wait a minute, he's talking about DNS RPZ, but it doesn't mention it. He's talking about DNS firewall. So Rod apologized for that, and he's going to try to correct it later. And of course, Johanna, because putting all these things together and putting 3 a day is a lot of work, and I'm really grateful for that. All right, so on to our quick talk. The DNS Response Policy Zone is essentially what we're doing is we're doing a specifically constructed zone, a DNS zone, so we can actually send reputation data down to resolvers. All right, so it's kind of what we're doing is we're turning a recursive DNS server into like a security hammer, where it can actually do things to stop things. This is not like using DNS for something similar to this is not new. We have blacklist. We have, you know, the real-time blacklist systems. We have different sync tables. There's a, you know, this is not like new to say here's a blacklist and put it in there. What we're doing here is a more efficient way and a more effective way of actually doing this, so we can take a blacklist, take something where we see here's a command and controller, and distribute it out across the internet really rapidly. And in a safe way. And we know how to do that with transferring zone files, and that's where some of this came from. So catching up to make sure we're on the same page with the principles. Over on the right side, typical DNS resolution. You know, I got a computer, I'm going to need to go somewhere. What do? I go to my DNS resolver. My resolver then says I have nothing in my cache, so let's go up to root. And then root says go to the TLD. And then the TLD says go to the authoritative name server, and the authoritative name server goes to the delegated name server. Pretty typical of how that works. But the key thing here is you got that cache and resolver that I'm talking to. I send a query in, and the cache and the resolver does the work. All right. Over on the left side is how these the primary and the secondary, or the master and the slave DNS servers actually talk to each other. You have a master, and he's able to push out to the slave a zone file. And he first pushes out with an AXFR, and then all the incremental updates, he's doing AXFR incremental transfers, right? This is all secure. It works really well. The internet's glued together with this technology. So this is like not new concepts here. What we're doing is we've created a module within the resolver where you can we turn the resolver into a shadow slave. So over on the left, we have a master DNS RPZ server. It's basically a master DNS server, and it's serving out a zone to a slave, which is down here, which is a caching resolver. So this is a security company. They have a blacklist of bad domains, and they want to get it out there to a lot of people really quick. This allows me to talk to many, many different slaves and push out very expediently. And then because I have a combination of the AXFR and the IXFR, whenever I have updates, here's like 5 new domains, here's 2 new domains, here's 100 new domains. I don't have to send the entire list again. I could just do updates. I can say, here's 3 deletions because they are not bad anymore, and here's 2 additions. So I can do these updates, incremental updates, and keep the incremental updates going, and it's really efficient, right? The resolver isn't doing, the queries back and forth, so it's less load on their part of it. All right, so this kind of works really well with that. And then you would look at this and say, wait a minute, what about DNSSEC, right? And this is one of the slides we have to go through. We had questions earlier today. What about DNSSEC? If it's in the blacklist, right, let's say here's my list of 300 domains that are bad, then basically it turns off DNSSEC for those, right? And there's a blacklist. But if it's a good thing, right, say, google.com, I'm going to google.com, well, google.com is not in the blacklist, and DNSSEC works perfectly fine for those. So those things that are being signed, and they're not in the blacklist, A-okay. Those things that are in the blacklist, well, they're bad, right? And ironically to this, as we deploy more and more DNSSEC into the industry, it's going to basically shine a light on the good stuff, and then the bad stuff is going to be unsigned. Because the bad guys won't go out there and spend the money, time, and effort and build a accountability trail to them to sign their zones. Because once they sign their zones, there's an accountability trail that says, that's where you're at. You can trace back. So the long-term answer to this is rolling out DNSSEC everywhere. And then people can just say, well, I don't need RPZ anymore because I won't talk to anything unless it's signed. Right, and so that's a long-term answer. So also with DNS RPZ, this may be a temporal, a technology that has a life cycle that you get down the road, and if we get DNSSEC everywhere out there, then you just have a policy that says DNSSEC only. Now, putting this in action, you got a bad domain out there, xyzbadness.com, right? So that's a bad domain. It's like maybe a command and controller for a botnet. You have this huge community now of operational security groups, organizations, institutions, universities, all work together to find the bad stuff. We're having really good intelligence on finding the bad stuff. And then we have certain people in the community that are organizations, Spam House, Herbal, Internet Identity, groups like that. They actually take these lists in and build these, and they do it as a service, as a subscription model, different ways. They have different tools that they use to get the list out there to different people. And with these, they then say, well, here's this compilation, this level of effort, and here's my bad list, and now I can send it out to a cache and resolver. So now what happens is a spam run comes in. Badness goes out there and says, I'm doing a spam run. Email comes into my computer, pops up on my screen, and my computer, since it pops up on my screen, wants to go look up the graphic file on the badness.com website. Well, when my computer tries to look up to find out where badness.com is located, it hits the resolver. The resolver says that's blacklisted, and instead of getting a graphic, I can't download the graphic. It just doesn't work. So that's like stop it. You can also do things where all of a sudden instead of get a graphic, you get here's a little web page because I put it over to a walled garden and say, you're going to an infected site. Don't do that. Or call your IT department, or your computer might be infected. So there's different things you can do with that. Now, is this different from other ways of doing it? Well, the key thing is many other technologies either rsync and move big files over, or what they do is query per domain. So in other words, an email comes in into your MX server for email, and then I look up the domain and to a real-time blacklist and say, is this good or bad? It comes back and says it's good. Next one comes in, is this good or bad? Okay, it's bad. Okay, don't process it. Next one comes in, good or bad? Okay, that's bad. It's very transactional. Because it's transactional outside your control, you can get a lot of emails coming in, and then you're having to spend the time and effort with it. So one of the things that this technology from the people who provide the blacklist and the people who do the process and the process, the lookups, both sides are saying like, wow, this is pretty attractive because it saves me a lot of overhead. The company that produces the blacklist, they don't have all these queries hitting them, and the people who are actually trying to do the checks, they don't have all those queries going out. So it actually simplifies things for them. So that's been one of the excitement areas around it. Putting this in action, and during a recession, jobs are tight, people looking for jobs, a spammer knows that, spammers are going to take advantage of it, or a phisher or a bot herder, and they'll send an email message out and says, oh, come work at home, come to my site so I can infect you. Now, of course, we can find these guys now. We can take one domain and we can start farming out with DNS RPZ technology or DNSDB technology, and we say, oh, here's the next 100 they're going to use, and we can blacklist them. So now once we blacklist them, somebody gets that and they'll get a blank. They go, wait a minute, it's not going anywhere. And if you lift up the hood and look behind the scenes, on the resolver, it will be blacklisted. And that's what we're looking to do. It's a technology helps that out with it. What's also an advantage here is you don't have to do with one company. You can do many different ones into the RPZ, right? So you have security company 1, security company 2, then you can have like a incident server. Within the next year, we're probably going to have an incident server out there. So these are things like the industry has taken down a botnet, or the Interpol has taken down a botnet, or the FBI has taken down a botnet. And here is the RPZ feed that you can tap into so that you make sure that your infected computers who are part of that botnet, 1, they don't connect to the botnet, 2, you can identify them so you know which ones you need to call up and get cleaned up, right? So we will have those sort of things up there. You can connect those up, all up. And then, of course, you probably want to have your own. So you have your own tool out there because you may want to do other things. You may want to do things like whitelist some of your policies. You can put that in the config file. You can do that on a server. You may want to do overrides. You may have your advanced persistent threat sort of things. People are trying to break into your network. These sort of things, right? So those are interesting, that you can add up on with them, right? So it gives it an advantage. During the first and the early trials of the RPZ, people being like early adopters playing around with it, the 2 primary key things that people are using it for is they'll get like the bad domains, the malware drop sites, the phishing sites, the spammer sites, the command and controllers for botnets, and they've been using those to make sure that their computers, their employees' computers, their customer computers are not going to these sites, and they're using it for that. And they've been quite happy with the way it works. We have several of them playing around with doing this with walled garden or supplementing their existing walled garden. So this is a technology where if I went out and clicked on a domain and the domain was bad, I can set up a rule where it redirected me to a different site. So I would not go to the bad site. I would go to a site that would say, you're going to a bad site, right? Google and their services does some of this, and some of the other resolver services, that sort of thing. And you can do the similar sort of thing for yourself. PTR lookups for reputation database is another third thing that people have been playing around with and doing. Where to use it, the use cases are all over the place. And in subsequent materials, we're going to come up with a lot of interesting use case models to give people more ideas as we work on pushing these out. But like in enterprise, big time and supplement your existing security tools. It really help things out and let your NOC know that something's going on with it. Keep infections from spreading inside of a network and contain it. Host and provider, interesting scenario, because host and providers, a lot of times you go out there and or a cloud provider, you would say, okay, you rent some cloud space. Well, on that server, yes, you may be able to configure up and make a DNS resolver out of it, but a lot of times they say just point to our DNS resolvers. And these sites are always getting either the criminals are buying space on it because they make money and they'll actually pay for hosting equipment, or they'll steal it. And this putting on the host and provider's resolvers allows the host and provider another tool to either contain problems or identify problems, right? So it's an interesting use in that scenario. Service provider is really obvious because somebody goes out there and uses the resolver, and with this technology, they're able to identify people going to bad sites. Maybe you use it to redirect them to go to cleanup sites, as part of a remediation process. Or offer it as a service and say, hey, connect to these DNS resolvers as part of our package that helps clean you and keep and protect you. So you can, maybe make some money off of it, selling it as a service. What we're doing right now is getting the word out more. We have a healthy amount of pre-announcement, and the operational security community is rock solid behind this. A lot of people like this technology as a new tool. It's not the ultimate tool, it's just a tool in the toolkit. So you got to engineer your network in there. But because the operational security community we're starting to build the ecosystem that we hope. As you saw, we got the first three who have raised their hands and says, yes, tell everybody about us with Span House Serval and Internet Identity, and we got more coming. We got some boxes that are not DNS resolvers coming out that are security boxes. They're like appliances some of you may already have in your network, and they're coding this as a feature. So they're using DNS RPZ as a feed to come in, and then with that feed, they use it as part of the protection mechanisms to, look at traffic and things like that with it. So we got those coming out. So it was time to get the word out. And then we have Bind 981, which is the production version. We usually don't like to recommend people to upgrade to a 0, like a 980. We wait for that first version to come out there because we've had enough people try it out. We've had people baked it in. We've had people done some operational deployment tests, and the bugs will come in, and we'll be able to get, have a even more steady handle on it. And then, of course, we run the latest production code on ISC's infrastructure, from FROOT to SNS and other things. So we got good stability measures there. So we can confidently say, okay, this is an upgrade version. So that's time to get the word out. ISC, our role with this, ISC, we're the tools guys. So we're not going to be doing our own DNS RPZ feed. We may be involved with an industry feed for taking down a botnet, but not a feed that you would subscribe to us. Our role is we write the specification, we come up with the code, we make the code open source so it's referenceable by others. So if you're a vendor and you want to see how to do this, you can see our code and figure out how to do it. We work with all the potential blacklist providers. We get their feedback. We help improve the code from that. We talk to the people who operate and deploy it. We get their feedback and work improvements with it. So our role is to build the hammer. And we'll build as best of a hammer as a new tool in your toolbox as possible. Feeds, we allow others out there to do it. Others will have a better specialization to do the feeds. So we leave that to others. So now what we do is we're at the questions part. So if you go ahead and type your questions in, Johanna will walk through them. And then while you're listening to the questions, here's some links on here. One of the first places you can go to sign up if you're going to get involved with DNS RPZ is we got an alias up there, the discussion list. That we have the coders, we have the Bind 9 guys, we have ISC people, we have people who deploy the blacklist, we have people who deploy the software, we have just interested security people. They're all on there, so it's a very good list to actually ask the questions. We have articles from Faro Vixie, you can look at that. We have the draft specification, and then the place where you can download Bind 981. So let's go on to our question parts.
Okay, so our first question is from Hisham. Does DNS RPZ respond quickly to fast flux caching DNS?
Can it respond to fast flux DNS? One of the tool sets that ISC is involved with the Security Information Exchange, puts the data sets out there that companies can actually spot the fast flux and keep up with it. So as domain names are rotating, like for instance, as a bad guy will rotate through domain names, which isn't necessarily fast flux. Fast flux is more of the IP addresses moving around, right? It's the same domain name, it's just IP addresses moving around. You can also track the IP addresses, but most of those IP addresses are home computers and infected computers. So trying to blacklist those sometimes would do more damage. But what you're looking for is as bad guys rotate domain names. They go from domain name 1 to domain name 2 to domain name 3. They're actually burning through domain names. And this is a capability with the IXFR transfers. I can keep up with it and start, here's the next domain name, here's the next one. So as they rotate, you can spit out the next one. And it could be spread across really, really rapidly.
Would the NSIP facilities in our RPZ rule help against fast flux? That is to blacklist any name whose NS server is in various blocks of addresses, on the idea that perhaps the NS servers don't move quite as fast as the servers themselves? Possibly
tracking it from that aspect of it.
One step back, not the NS servers themselves, but the NSs for the NSs.
Yes, yeah, it's possible you can be doing that.
Okay, Eric just sent a message saying fast flux, the answer is yes.
Eric being very succinct.
Okay. Okay. Next question is from Hisham as well. Does Master RPZ server service available now? I guess is Master RPZ server service available now?
As in the blacklist providers, yes, they are, and we'll be pointing out all the details for them. so you can know who to call up.
Okay. Eric mentioned, okay, there's a message here that another advantage of RPZ can base blocking based on our data, not just host names used by traditional blocking methods. If you know an IP address is bad, all names pointing to that address can be automatically blocked. Okay,
right.
That's the message from Eric.
Right.
Okay, next question from Hisham. Can we create our own internal master RPZ server?
Yes, and it's actually that one of the things we pointed out was that's one of the advantages of it, because you can create your own.
You probably want to have your own, to whitelist your own IP addresses and names.
Mm-hmm.
Okay, we have one more question. Oh, sorry, are you ready for the next question?
Yep.
Okay, we have one from Afan. How do we know statistics of block query from DNS RPZ?
Go ahead, Vernon.
In the Format 3 version of RPZ, what Paul calls Format 3, I think he calls it Format 3, something 3, there is a log channel called RPZ that logs stuff. I don't remember if it counts stuff, but it logs stuff.
Right, and the counting will be, we'll probably get more, as more people out there, statistics of knowing whether they hit percentages, and so you can do things with it. So that's the next item, the next improvements we're working on there for RPZ. Okay, so let's go ahead, keep on typing your questions in. We'll go ahead into the next section, and then we'll do another pause, and then we can continue on with it. So in this section, this is why we need DNS RPZ. You go out there and look in the world today, we've basically got these criminal clouds. You know, you got cloud computer networks out there. Well, we got criminal cloud networks. And these are systems that, you know, bad guys go out there, they steal resources, sometimes they buy it, and taking stolen resources from hosting providers and people's homes and things like that. They actually build these pretty complicated and robust networks. And so, you know, it's not like, you know, one hacker anymore. These are actually complicated criminal organizations with a whole ecosystem behind it. So you get, here's one player in the ecosystem. This is a bot herder. Bot herder's job is to go out and build and break into computers. It's basically what he's doing. He's breaking into computers, and he'll use those computers to go out there and do what? They'll take the computers and build other botnets and other things with them. And perpetrate crime. So here the bot herder gets up, he's got a list of domains on his TLD, his domain server, and he'll pick one of them he's going to use for the day's activity, and he'll stage out on his own name server, which is usually broken into a computer. And then he'll go out there and stage his infrastructure. So he'll go through a proxy, connect to his malware server, take his malware that he's leasing or buying from somebody else, because he's not doing it himself. He leases it from a specialist who writes, you know, crimeware that breaks into other computers. He goes to a packer. The packer obfuscates it, so that way antivirus has a hard time spotting it, and he sets it up on his drive-by server. Then he's got to get people to come to his drive-by server. So he doesn't write his own spam anymore. He basically outsources to spammers. So you have other groups who have spamming infrastructure. And with the spammers, it's like he fills out an order form. He says, okay, I want to target guys in Washington, D.C. Washington, D.C., it's the fall. A lot of government people are into American football. I want a spam set up to be about fantasy football. And you'll have people who take that form, they'll construct a spam email off of it, they'll give him the graphics to load up on his drive-by site. He sets up his drive-by site that looks like a fantasy football site, and he'll go out there and start doing a spam run. And people will get the emails coming in, say, hey, fantasy football league, special discounts, and people go, oh, that's interesting, and they'll click on it. And as they click on it, they'll go to the drive-by site, and what they don't know is they're clicking on it and say, what is this? It's kind of weak, there's not a lot of stuff in there, and they don't know it, but the computer is getting affected and it's owned. Once it's owned, you know, that computer then shuts off the antivirus, which is a standard operating procedure for the anti-malware. Then it calls up to a secondary server and says, okay, let me get my secondary malware. And then I'll call home to the, you know, the bot herder, and the bot herder goes like, oh, okay, here's the complete inventory of what the system is. I'm inside of a government institution. What else can I break into? So let me download a second module, and that new module will go out there and start connecting to all the other computers in there and seeing what else I can break into. What do you got here? An advanced persistent threat sort of activity. So an interesting thing going on with it. This is going on all the time. Now, what's interesting about all this I just highlighted is that at this stage of the game, because of what we can do with our forensics ability on the net, is we can spot these bad guys. We can find them. We can see the DNS servers, the DNS addresses of all of them. For a lot of these things, if you look up in the blacklist, they're listed in the blacklist. So if we're already getting things in the blacklist, what we needed to protect that computer, the victim of the crime, is we needed to stop the computer from doing the DNS lookups. So if we only had something that would say, as I do the DNS lookup, and if it's blocks listed with RPZ, then when the first email came in and I went and clicked on that fantasy football site, that particular domain name would have been blacklisted and the whole attack vector wouldn't have happened. So that's what we're looking at. And also triggered a knock, so the knock knows that somebody's trying to actually do a spear phishing attack at me. So this is based off of a real world example of several people where this stuff was happening with. In the scenario that I encountered personally, I had a shadow server, which is a sister organization. They'll send anybody with a network, you validate network, and they'll send you reports of what the bot infections are coming in because they look from the outside in. So I got a shadow server report and says, yesterday you had 16 computers get infected. And when we did the forensics, all 16 computers were up to date. In other words, totally patched, right? They had antivirus was up to date, okay? Totally up to date, new signatures and everything. Everybody was using Firefox. Everybody was using NoScript because they listened to my security presentations and they were all paranoid. Some of them were security people. In other words, they weren't, this is not the user's fault. The user didn't click anything they shouldn't click on. In this particular case, they didn't click on anything. They were looking at a very popular news site. They were having their coffee in the morning. They just got into work. They were checking things out on the news site. They were reading the news site, and an advertisement rolled over. As it rolled over to the Metasploit server. The Metasploit server then infected the computers with Java. It became the Java 20 patch from 2 years ago. It was a security advisory out there that it was basically a 0-day was being used for 6 months before Java got word that Sun, now Oracle, got word of it, and we got it fixed in industry. And so this is the scenario when the postmortem went out there is all the DNS that the bad guys were using, because we went back into our logs. All the DNS was already in the blacklist. And I went like, oh, wow, if I only had that blacklist on the DNS resolvers, it would have worked. I would have not had this infection. Because this particular infection, Medbrutorpig, was very, you basically try to move all the data off, try to clean the data off, but you basically have to totally reformat from low-level format of the hard drive because you can't clean it up, you can't disinfect it. So that's a use case scenario, and I'm sure over time as we put more materials out, there's more different use case scenarios as people say like this is where it would be very useful. So now for some more questions. And again, here's some more materials out here. Like you say, okay, if I want to get DNS RPZ and I want to get upgraded, where do I get help? Again, there is the mailing list out there for DNS RPZ interest. You can check out the knowledge base. We're going to be creating a whole series of articles on DNS RPZ on our knowledge base for ISC. And then we do support. Everybody gets surprised when I tell, oh yeah, ISC supports bind. ISC codes bind, and we support bind. And our support is geared towards critical infrastructure. So it's critical infrastructure support, because we support, root server operations, we support top-level domains, we support big ISPs, and so if you need help with upgrading with support, we got that sort of packages too with it. So Johanna, back to you on questions.
Okay, we have one from R. Dennison. Assuming an attacker preloads DNS responses in target caching resolver, will the RPZ data overwrite the existing record, or will this require cache flushing?
I'm not sure about I'm not sure I understand the model. Perhaps the answer is that RPZ works on the output of the cache. The cache is always correct in the sense that it's whatever the protocol says should be in the cache. and then the RPZ policies rewrite the answers on the output of the cache. There's a whole separate question about validating the cache and validating NS servers and so forth. It's not even clear we should validate. It is a whole separate thing. Is there any clue that I might have gotten close to the right answer or the question?
There is a reply from Eric. RPZ prevents the name server from doing lookups. So if it is in RPZ, the server won't stick the data into the cache.
But that's not exactly true. RPZ does not prevent lookups. One of Paul's big hot buttons is that the cache is always correct so that the lookups are done. What RPZ does is to rewrite the answers on the outside of on the downstream of the cache. It does the DB finds, and then it smashes the result of the DB finds. Rewrites. I'm sorry, I shouldn't use a word like smash. And so, if the bad guy has somehow preloaded the target's cache, I'm not sure what he'd preload it with. If he preloads it with good stuff, you don't want to rewrite it. If he preloads it with bad stuff, it's the same thing as if he doesn't preload it, and the bad stuff just comes off the wire. In either case, the RPZ rule will say this query name or this RData or this the NS name or the NS name for one of the NS's back up toward the root, or one of the IP addresses for one of the NS names. It requires a rewrite. Then the rewrite happens, but the cache remains. The cache remains the same as it always was. Mm-hmm. And if you don't have the, if in a future version, we'll probably be able to turn this following feature off. That is, RPZ only rewrites queries that have the recursion requested, the RD bit set currently. Mm-hmm. If you don't turn that off, you can tell you can distinguish what's in the cache. You can tell what's well, let me start over. You can either rewrite or not and compare the rewritten stuff with the not rewritten stuff by doing dig with and without the RD bit set.
Wow, okay. Interesting. All right. Any other questions queued up, Johanna?
We don't have a question, but there's a statement from Eric that I just wanted to read out quickly. Says, don't forget, maintain your own for organizational whitelist or blacklist.
Yes, that's an important point that Eric made.
Right. So, and it probably will be as part of our next, as we work towards a deployment guidelines, best common practices for deployment, things we'll point out with it. Okay, so let's get into some more details of DNS RPZ. Let's go back to original problem statement. This is from one of Paul's presentations where he's talking about DNS as a decentralized system. It's distributed autonomy. It's got relationships with operators and owners which are tenuous and resilient. And the result of all that is a pretty solid naming structure for the entire internet, and it's working in all sorts of different ways of helping to expand where, as the phrase I like to use, long live the internet is dead. It's all telecoms now because we have mobile systems and, SCADA systems and factories and, street lights and the Internet of Things. Everything is just kind of growing and interconnecting, and it's all dependent on DNS, and it's working really solid and really well there. Key thing we need is more security with DNSSEC and things like that. The other problem we got out there is a split between the registry, registrar, and registrant model that we have right now. It insulates all the parties from responsibilities. So we don't have we have a lack of accountability. And complaints are ineffective, so you go out there and say somebody that's a bad domain, it's like it's hard to do that. And there's a lot of controversy around this. There's a lot of discussion. You go to ICANN, and you can follow along with all the dialogue and discussion there. ISC sends several people to ICANN all the time, and we get involved with that at times to try to keep sanity to this whole thing. But in the meantime, the cyber criminals will take advantage of things, and we have to do something about it because the cyber criminals are actually victimizing people as we speak in outrageously large sums of money. So something needs to be done. So that's where this came out. Now, doing these sort of blacklists is not new. There's a long history here, and you can read through the slide here that, we got these things out there. We're not the only ones doing things, right? So we're not the only ones acting. Nominum's got a feature in a product, OpenDNS, Google, Community DNS, all these organizations are doing things so they can, as in the resolver function, so you can do things actually with these blacklists. The issue with it is we don't have a common and effective technique. So if we want to actually take back the DNS, we need to be able to say, here's a bad domain name, or here's a name server with 300 bad domain names on it, and we want to take these guys out. In other words, we don't want to have any victims talking to them about how do we do that, and we want to get it across the internet really fast. And for that, we need to have agreed upon, way of doing it. And this is what we're endeavoring to do with the DNS RPZ, is to have it a way where use case-wise, we could say, here's a group of 100 domains, and we want to shut down these guys from using these domains at all. So we'll go out there and push it out into a blacklist. So that's what we're after. We're building upon technology that's been proven out there. Incremental zone transfers, notification of zone changes, dynamic updates of zones, TSIG, all these sort of things, we're kind of building upon it. So it's not like we're using something brand new technology. We're using things that are tried and true, which it goes towards operational confidence. So a lot of you who say, should I deploy this or not, this kind of goes along the path of operational confidence. Well, I know we're using, all these, RFCs and TSIG, we use these day in, day out. So we know it works. We're just using it in a creative way. We have some history with it now. So in the beginning with the version 1.0, that particular version was released as patches. The different people, in this case, I wasn't at ISC, it was over at a network side, and myself and a bunch of other people would be talking to Vernon and Paul, and they would be collecting the input and saying, okay, let's try these, right? And they came up with the first set of rules of saying, here's what we can match against, and here's actions we can do with it, right? And they came up with a specific model, and then lessons have started being learned with it, right? So with this, and this is kind of like a diagram just to put things in the frame of reference with it. So in this first model, you got things like, for instance, if I had a example.com as a name and I want that blacked out, I don't want anything to go to it, I could just put it in there and say, black it out. That means nothing returns. It's blocked out. It's blacklisted. If I want all the subdomains of example.com to be alias to walled garden, in other words, here's a domainer and they have these weird domains. They have like XYZ423XY4, XYZ4234258, and they have the whole list of them. It's funny with our passive DNS work, we can look in a database and we can see one of these things and we can see this huge, thousands of these things being created, right? Well, instead of putting thousands of them in there, I just wildcard it. That's all example.com. And if anybody in my network goes to that, I want them to go to my get well page. So over on WGISC.org, that can be my walled garden. And if you click on it, right, you click on the domain name, and if you have a direction that says go over to here instead. Instead of going to the phishing site, I go to this domain and it says, you tried to go and download from a bad site. Please don't do that, or check your computer or something like that. People have seen these sort of things out there before because Firefox uses that with the Google services. Very similar to that. And then here's another example here is I want it redirected to a record. So I can redirect it to an IP address versus a domain. Some other examples out here, I got partner.com, I want it whitelisted. Here's an example where I want it to appear empty for a particular domain, very explicit here. I could take a whole range of IP addresses. So if I want to do a /24, I can express it as a /24 and redirect it that way. It works with IP version 6. So here's an example of V6. Well, I want a range of it, and you notice in here with the colons, we use in ZZ to equal the colons in here, so it works with V6. So we got a range of examples there. Now, as the lessons learned with it, once this first version came out and we started building a community, Paul and Vernon was starting to get really good feedback, because they were thinking one thing and then say, oh, well, and then people started working with them and they started doing the improvements. So this RPZ format number 2, as you heard from Vernon said, they're now working on format number 3, but format number 2 is what's in bind 9.8. So 9.8.1, which is version we're talking about right now. And this is a slide that kind of like points, I should have put this earlier in to explain things, but what I get to is this one is the RPZ Format 1. This is the first thing they came out with. We have different triggers, and then you have the actions you can do with it. And then with the feedback came in their Format version 2, they got new triggers you can do, and they had another new action in there. And then they're working on, in Format number 3, they're working on more things in there. Now, Format number 2 is in 9.8.1. Now, how do you keep up with it? Well, subscribing to the RPZ community, you know, the places I pointed out to you before, those are when notifications will come out. And what we'll be coming out with is we'll have patches for 9.8. So if you upgrade to 9.8, there'll be patches, right? So you can be on 9.8. If you decide to move to 9.9 comes out, you know, next month. 9.9 we'll also have patches for that. And then the next integration part for the Format 3 and maybe even Format 4, depends on how much work involves with it, will be in the 9.10, and we integrate that up in production. So we'll have patches available to you, and then later on in the future, we integrate it all up into the main line. So that way we can keep on evolving and working with you with this different sort of feedback. Here's a sample configuration from Paul's house. You know, he kind of obfuscated where he was getting the feeds from, but he's got different policies he's using with it. So it's if you're used to the named.conf, it's just, you know, some more of the language within the named.conf. One of the nice things also particular that's very attractive to the blacklist providers is update the IXFR capability, because that allows them to not have to build out a infrastructure that keeps on sending big files all the time. With the IXFR, say, here's an update, here's an X update, here's an X update. And I'm not sending the whole file again, I'm just sending the updates. And that update capability is very attractive from a scale and capacity standpoint, from the provider standpoint of the blacklist, and also the people who consume it, because it means you don't have to actually scale things up with it. So I'm looking forward to the people who operate big mail servers. I'll be interested how, as they look at this, how this can help scale their operations. We've been talking all about the possible good. There's all sorts of good possible things on here, but there's also possible harm. And the point, the key point with this of the possible harm part is to remember this: DNS RPZ is not something that you can actually strongly impose on somebody out there. You know, so as a censorship tool, it's just easily bypassed, because the internet is built on this end-to-end model. In other words, control points is on endpoints. Like, you know, of Eric and Johanna and Vernon and I decided, oh, we're going to download a new app and we're going to talk with each other. We just added value to the net because the four of us decided to type a new app, and we just loaded it up and started working with each other. Now we can work a new app and we can say we'll do our own, you know, DNS infrastructure, because we can tunnel things across. You know, it's hard for somebody to get in our way with the internet architecture. That's what's one of the reasons why the internet architecture has grown so fast, is because Johanna, Vernon, Eric, and I can get together and we can add more value to the net, and nobody's going to stop us as long as you have this, you know, the TCP/IP and the whole glue in between the DNS infrastructure. So if somebody tries to get in the way with that and say you have to use this RPZ blacklisted censorship resolver, we would just say, oh yeah, we'll just go around it. They say, oh no, I'm going to block port 53. It says, okay, well, I'll just use a different port. Nobody says your DNS lookups have to be on port 53. I'll just have somebody out there who has a different port configured, and I'll use that port. So, well, I'm going to stop that. Okay, well, tunnel around it. Let's see you stop encrypted tunnels. You know, there's all sorts of way around it. So when some people are worried about this with it, they go like, we go, okay, it's an opt-in. I want DNS RPZ, I want that blacklist to protect me from getting infected, right? It's very much an opt-in technology, not something you can impose. So, so yes, people might be able to use it for possible harm, but it's not one of those things that's, you know, imposed out there. So time for more questions. And in there on the possible harm, if you're really interested in this and reading some more why it just won't work, there's a paper that Paul Vixie and others, other of his peers in the industry wrote up, the response to the Protect IP, and this is kind of the link to it. And also another reading that download at your leisure is Rod Newson talking about the DNS firewalls. This is one where he kind of apologized us because the editors pulled out the DNS RPZ part, but I put a little comment in there pointing to our webinar so people know that the webinar is going on. So questions, Johanna? Any questions queued up?
Okay. There's one remark from Eric. This is with regards to Hisham's question about fast flux just now, so I just wanted to read it out quickly. The answer is yes, but you have to make sure you don't put the name servers in there that host domains other than that domain. So I just wanted to read that out.
Good point.
Okay, so we have Vernon, you were about to say something?
No, I just had good point.
Yeah.
Okay. Okay, so we have a question. Oh, this is from Eric. Regarding dynamic updates and IXFR, I don't know how to pronounce that. How long does it take for doing an update on the security provider's name server to the update being actionable on the name server being used by the customer space?
From the service providers to the customer's base.
I think the answer is how long does it take for an IXFR to get out to a slave server? And I think it's pretty quick.
Eric said yes. So. Okay, so you answered. Oh, and you said seconds?
I've heard seconds.
Yeah, it's from our data experiences in seconds. That's one of the reasons why using this technology. It's really fast. Okay.
Okay.
So let's move on to
don't see any other questions.
Let's move on to the providers now. There are more providers coming. Here are three who raised their hand last week and says, yeah, I'll do some slides so we know what people point to. And some of these are the ones you might already be getting blacklists from. Spam House is one of them. You know, very famous out there on the net. They do a really good service out there, and a lot of people use them. And here's where the information is published on rpz@spamhouse.org. And here's the email. They actually get access to it, and they actually have a good FAQ on the memo there for how to access the trial and things like that. Another service which is going beyond spammers is Internet Identity. It's actually pulling a whole bunch of different data sets together for malware distribution, phishing, spear phishing, data exfiltration, and a whole bunch of stuff. So you get their edge is they want to say we got a richer set of RPZ data set. So it's more beyond the spammer sort of stuff out there. So they say here's a richer data set, and you got Internet Identity's URL down at the bottom that you can contact and find out more about those services. And then you have Serble. And this Serble, you know, was one of the first ones that came out and says, yes, we got it. Arnie down here, his contact information is with that, so you can contact him and he'll hook you up with it. You know, so they're also one of those old timers in the industry that people get a lot of blacklist information from. So, and now, of course, all throughout this, you may say, hey, I got some questions. I don't want to ask it during the webinar. I may not want to ask it on a public mailing list. Who do I get? Who do I call up? Who do I contact? This alias right here, DNSRPZ@isc.org, this gets you to the authors and to Eric and I. Right, so Eric and I as the people who advocate and deploy and do stuff, and then Vernon and Paul. So you don't have to remember any of our other addresses. This DNSRPZ@isc.org, and then you can contact us with these questions that you don't want to bring out on the net, or in a public alias, or you know, on the webinar. So so now if we got other questions, this is the time to ask, because that's the last we got. And as you're thinking about your questions, those of you may say, well, I'm on bind 9.8, I'm on bind 8, I'm on bind 9.2. How do I upgrade? I may need some help. You know, so we do special, you know, we do support. And for this webinar, Johanna is going to email out a discount code. So we got these basic support packages we recommend to people who are just starting out with bind support, and we'll give you guys a special significant discount, which is over 40% discount on these sort of things. So you guys say, okay, if I need to talk to the experts. And the interesting thing about support with ISC is, as one colleague over at Time Warner Cable said that, you know, compared to all the other vendors he has to spend money on support with, ISC is the easiest, because he says he gets 10 times more help with a tenth of the cost. And of course I go like, okay, that's good, you're happy, but it's a tenth of the cost. So us being a nonprofit open source company, we're able to keep our costs low with it. So So you can take advantage of that, and because DNS is critical, if DNS goes down, your network's down according to your users because nothing's working right. You know, it's having a ability to call into the experts is always a good safety blanket. Any further questions, Johanna?
Okay, I just received a chat from Hisham to say thank you. I now understand better. So, and I have one question from R. Dennison again. Will there be updated copies of the presentation on IC website? So yes, the answer is yes.
Right. And we'll let you know the specific. I think Johanna will just let people know the specific location for that. So.
Yes, it is actually mentioned in the thank you email that will go out following this webinar. And we typically put it up within 2 business days, usually sooner.
Yep.
That's it. I don't see anything else. Our Dennison said many thank you. Your work is greatly appreciated.
Okay. Thank you, everybody, for attending. Really appreciate everybody out there, and looking forward to many of you trying this out and seeing how it works. Also, spread the word. Tell people, hey, there's this technology out there. And as Johanna is pointing to the webinar recordings and the PDFs of the presentation, and then over on the knowledge base, we'll have a lot of materials on the knowledge base popping up. Please point into that, because this is a hammer, a tool, and a security toolkit we're trying to get deployed widely out there.
Okay. To those that put in thank you notes to us, thank you so much for taking the time to write to us.
All right. Thank you guys very much. Thank you, Vernon.
Thank
you, Johanna. Thank you, Eric.
Thank you, Barry. Thank you, everyone. Bye.